Moment of truth. With Sysbench, we squeeze the CPU with a single thread, and the results are brutal. Stay and see real performance. Then, Hashcat destroys CUDA cores. From the speed of MD5, we go to the technical demand of SHA-1. Will it hold up? Watch this now. SHA-512 devours resources with extensive hashes, but the average was flawless. If you want maximum performance, stay until the end. This time we will install, review and evaluate Ultramarine 44. From the website we press the Get option and see the choices. The installer, the device and architecture. We download the KDE Plasma edition. Ultramarine suggests this desktop environment. We boot the image and wait for the system to start. When finished, we see the KDE desktop environment and the welcome screen. Then we run the installer. It asks for the language, select your preference and the keyboard layout that you currently use. We select the disk and the installation method. In my case, I use Erase Disk. Then we click on Next and Install. Ultramarine 44 is based on Fedora 44. It seeks to be a very fast operating system with desktop environment innovations. When the installation is complete, we press Exit to leave desktop. Then we manually restart the computer to boot into the system. Now the system boots up. The speed of the first boot is average. We select the language and the keyboard layout of our choice. Then we type the name of the device, for example, Ultramarine. Next, we provide the full name, the username, and the password. We confirm the password. Press Next. Then comes the network configuration. We are already connected. Then Other configurations. Upon completing setup, the system will finish the install process. It also installs necessary packages, then restarts automatically. The system boots up again. We enter the user password and wait for the desktop environment to load. Then the welcome screen appears. We observe the options on the welcome screen. While performing the configuration, two errors appear, an applet and a system report. We open the terminal and increase the font size then. We update the system with DNF update, waiting for it to download and install. Now with DNF installed, we install FastFetch and Sysbench. These packages are used to see system info and do performance tests. We run FastFetch and see that the kernel version is very recent. The idle memory is quite high and megabytes per package are low. We execute commands to contrast the information regarding the distribution version, the kernel version, and the overall memory use. Then, we check the consumed disk space. Now, we verify the boot time minus the firmware time, which turned out to be average. We run Sysbench to evaluate the system. We tested the CPU with a single thread. The result obtained from this test was excellent. Then, we evaluate the CPU, but with 5 threads to see its concurrent behavior. The events per second result was actually very good. Now, we evaluate threads to see how concurrency is handled at the worker level in the system. The obtained result was quite average. Next, we test Mutexes with Sysbench to evaluate log efficiency. By doing the calculation, a very good value is finally obtained. We test memory reading to evaluate its management. The result obtained was completely average compared to other distributions. Now, we test memory writing to evaluate the speed at which data is written. The result obtained from this was truly very good. Then, we prepare the necessary files to test input and output. The sequential write speed obtained from this was simply excellent. We run Sysbench, but indicating it is to evaluate random fileo, that is, the hard disk input and output. The result was very low. Now, we run the top command. We run Firefox to analyze memory consumption per browser tab without loading any active extensions. We monitor the memory consumption per tab indicated by top. Now we open a second tab, but in this tab we load a specific video. Then we open a third and fourth tab to see the average memory consumed per tab. The consumption result obtained was quite average. We execute the NVIDIA SME command to check if drivers are present. But no, we check what packages exist and install version 580. With this, we install the NVIDIA drivers, wait for the installation to finish, and restart the computer when everything is ready. To verify that, we run post-grep acmods. As long as there are processes we must wait, we try a few times, and then we restart. This computer reboot will serve to load the NVIDIA module. We wait for it to fully restart and open the terminal for our tests. The command is still missing. We install the NVIDIA driver with CUDA. Then we run NVIDIA SME again, but it is still not found. We install the same package but change the version to 580. We wait for it to finish and test NVIDIA SME again. Now it is there. Next, we install GL Mark II and Hashcat. With these packages, we will test the graphics GLX on one side and CUDA on the other. We run GL Mark II and it uses the default card to render, which is Intel Shading measures the pixel and shader calculations well. Effect 2D evaluates accelerated 2D rendering. Desktop simulates a real environment to measure the performance of the compositor. Refract. This test simulates light refraction through transparent surfaces. The score obtained by the Intel card was quite average. Using env variables offload and vendor, we run GL Mark II to render with NVIDIA. Texture evaluates load and access. With the jellyfish test, it renders many semi-transparent objects in motion. Shadow evaluates dynamic shadow projection accurately. The conditionals test evaluates the use of conditions inside shaders. The score obtained by the NVIDIA card was completely average. Now we run Hashcat. I note that device number 1 is the GPU. If it says CPU, it is because CUDA packages are completely missing. We execute Hashcat B, which tests CUDA via hashes. MD5 is a fast method, while SHA-1 provides a higher security level. SHA-256 provides higher crypto resistance. SHA-5112 uses longer hashes and needs more resources. On average, it was excellent. The evaluation of Ultramarine 44 has finished. Now we will power off the system to share the final conclusion from the analysis. In conclusion, Ultramarine has an improved look, though it carries over bad things from Fedora, like drivers and slow disk speed. It has an average performance, improves Fedora in balanced and high-performance aspects. But in being lightweight, Fedora wins. The decision is yours. If you liked the video, subscribe, leave a like, and activate notifications. See you in the next video.